Hi, my name is Kasprowski and I'd like to present you our research entitled Judging Qualification, Gender and Age of the Observer based on gaze patterns when looking at faces. Quite a long title, but the research is quite simple in fact. Because we were meant to meet in beautiful city of Milano, I decided to use the photograph of this city as a background to make us at least feel like we are there. Okay, so as for our experiment, it was quite simple. We just recorded gaze signal of people looking at faces. The faces were with subtle teeth imperfections because this research is a part of a bigger study which we are conducting with dentofacial orthopedics specialists. But here in this presentation and this paper, we aimed only on the part of this data. So we just omitted this teeth imperfections and we just wanted to check if it's possible to learn something about observers analyzing their gaze patterns. The motivation is obvious, I think. Face observing patterns are very specific for humans. We can recognize other people's intentions or mood looking at their faces. And gaze patterns are used to diagnose different diseases, are specific for individuals, are different for races and for age. So it's an important source of information. The gaze pattern for typical gaze pattern for face observation looks like this. We look at eyes and look at the place somewhere between nose and mouth, typically. But what differs different gaze patterns of different persons, of different observers, is the duration of fixation, the order of fixation, and so on. And this is the thing we wanted to analyze. The purpose of the research was to check if gaze pattern may show us gender of the observer, qualification of the observer, if he's a specialist or layman, dentist in this example, age of the observer, and gender of a person on the image. And we have done this analysis separately for layman and specialists. Our material, our data set was this presentation of 48 human faces images, and every face was presented for 6 seconds. And we had 53 observers, half by half, non-specialists and dental specialists. We recorded their gazes with 60 Hz sampling rate. And after removing the noise data, we had almost 2,000 observations, more or less half by half observation of specialists and laymen, more men than women, but on the other side, more female faces than male faces. And having this gaze data, we decided to calculate the metrics. We used some general metrics, obvious, like fixation number, fixation average duration. We used our area of interest metrics, mouth, time to look at the mouth, time of fixations, the duration of fixations on mouth. But I'd like to focus on the novel metrics, which we have used. At first, recurrence plot metrics, and then gaze self-similarity plot metrics. As for the recurrence plot, it was introduced by Anderson et al. In 2013. And it looks like this. We have fixations here on this and this axis. So we may say that this diagonal represents time, subsequent fixations. And for every point, we calculate the distance between corresponding fixations. For instance, between fixation number 15 and fixation number 35. And if the distance, special distance between these fixations is lower than some threshold, we have a red dot here. So red dot means that the distance between these fixations is lower than the threshold. Of course, on the diagonal, we have all red dots. And having this plot, we may calculate different metrics. For the first one is recurrence. So number of dots outside of the diagonal. As you remember, dot here means that the person returned with fixation to the same place where she or he looked before. Yes. Determinism is a number of diagonal lines, like here or here. The diagonal lines show that there were repeating sequences of fixation. So person looked here and here in fixation, let's say 19 and 20, and then repeated the same pattern, fixation 44 and 45th. Then we have laminarity, number of vertical and horizontal lines. So how many times the person looked at similar place one by one. And center of the recurrence mass is the distance of dots to the diagonal. If the dots are close to the diagonal, it means that the same fixation repeated close in time, so after a short time. When we have a dot here, for instance, it means that fixation 5, the location of fixation 5 was repeated in the fixation 48, let's say. So after a long time, the person returned to the same place. So higher value means that we have more such fixations. And the second plot we analyzed is Gauss self-similarity plot, introduced by Kasprowski et al. In 2017. By the way, I'm Kasprowski. Yes. And it's very similar to the recurrence plot. The main difference is that it doesn't use any fixation information, just the raw gaze points. And the distance between corresponding gazes is denoted, is showed here as a dot. When the dot is black, the distance is low. When the dot is white, the distance is very high. Yes? Just like this. And the main property about its GSSP is that it doesn't have any input parameters. For recurrence plot, we have a lot of parameters. We have algorithm for fixation recognition. We have this threshold, which we may change and have more and less red dots. Yes. Here we don't have any parameters. We just create a plot. And as you see here, once again, we have time on the diagonal, and fixations, for instance, are quite visible because they are black squares. Yes, these corresponding gaze points are close to each other, so they are all black. Yes, the points are black here, so we have fixations. Then when we have a black rectangle like here, it means that fixation number 2 is in a similar place than fixation number 7. When we have white, we say that fixation number 3 is very far from fixation number 6, and so on. So we just create a plot. And now this plot may be used, may be analyzed as an ordinary image. And we can use this image, different image measures to calculate something for this plot. And what we propose are 3 measures: homogeneity, contrast, and uniformity. Homogeneity measures to what extent nearby gazes are in similar locations. Yes. Contrast is sensitive to long jumps. Yes, we have long jump. It means that this distance between 2 gaze points is very high. To subsequent gaze points is very high. And then uniformity measures gaze sequences repetitions like here, for instance. And it's high when we have similar areas here. So these 3 measures, here are the formulas, but I will skip it because everything is in the paper. Okay, so we had this matrix, and we wanted to calculate if these metrics are useful to judge, to reveal qualification, gender, age of the observer, and gender of the face on the image. We used T-student, where the class was, we have 2 classes problem, like qualification, like gender. Maybe we are not very up to date because we assume that there are only 2 genders, sorry. Age of the observer was divided into 4 groups, so we analyzed them using ANOVA test, and gender of the face in the image, once again, 2 classes. So our result showed that there were significant differences for qualification, gender, and age groups, but sometimes the significant differences were observed for different attributes or different metrics. For instance, qualification was visible in contrast and homogeneity, and gender was visible for uniformity. There were no significant differences for gender of a face, so it was not possible to recognize the gender of a face having only gaze buttons. Here is one example, or two examples in fact, feature values differences for laymen and specialists, yes, for all features. And as you see, uniformity is not significantly different for laymen and specialists. So it's not a good parameter to distinguish laymen and specialists. But when we have gender differences, we see that uniformity is significantly different for female and male observers. But on the other hand, contrast is not significantly different. It was significantly different for laymen and specialists. It's not significant the difference between female and male observers. And so, as you see, there are significant differences, but sometimes not for every attribute. When we had this information about significant differences, we decided to use these features as an input to classification algorithm. We use the simplest nearest neighbor classification algorithm and tenfold cross-validation. And you can see the results here. For qualification, the results were quite good. For gender, the same. By the way, for qualification, females were easier to recognize than male. It happens. And for image gender, so for gender of the image being of a face on the image being observed, the results are very poor. So it's a bit only above the random level. So it was not possible to judge this. We classified also each gaze pattern into age group, and as you see in this confusion matrix, most were classified correctly. The group 40-50 had the best precision and recall. Group 50 plus had high recall, so most people with this age were classified correctly, but low precision because there were many people from other ages with other ages classified as 50 plus. So these are our results. And as a summary, new metrics, recurrence plot, and GSSP based proved to be useful for analyzing these patterns. Age, gender, and qualification of the observers may be found using these metrics, so they are useful. But of course, more elaboration is needed to establish the meaning, interpretation of these measures. For instance, what does it mean that the uniformity is higher for this and lower for this gaze pattern? Yes. What does it mean? We need to interpret. And this is a plan for future research. Okay, I hope we will be able to see each other in Milano someday. As you see, I've been there with my family, but I would like to be there again. Thank you for your attention and waiting for questions.